Okay. There we go. Hey, yay, it's working. Okay, so I am sorry I am late today. We are doing a really quick review. The purpose today is, here we go, screen share. The purpose today is pretty much to get you guys just an overview of what I have for you. And then I'm hoping the rest of the night you're spending getting yourself ready. So we're not going to do a big long night tonight. Yesterday's was an hour and a half. So you could definitely look at yesterday's to review. I'm not going to reteach everything from yesterday. I am going to show you this. I also want to tell you, hello. I did just post to eClass, which is part of the reason for my delay, is I've been getting emails from kids wondering when they have to wondering when wow, we have someone from Central. Welcome. Yeah. That's so great. I love to hear that. How in the world did you find out? How cool. But your teachers don't suck. We just have a lot going on, and I happen to be addicted to technology. So that's why I do this. So anyway, welcome from Central to Central. That's awesome. So this is going to be the last one. This one, hey, Jada, I'm just going to go over this crazy quick EOC geometry review sheet. If you are one of my students, I did just post to eClass the list of who's taking the test when. So please jump into eClass. I didn't want to put it in Google Classroom because I wanted to put it in the secure platform. So that's where you'll be able to access that information. Now, I know most of you just signed off to make sure that you had your information. Do you have to take the test tomorrow? But our goal is really to get this done. I know you guys are going to be great. We're going to really bust buns and work hard. These 2 pages are what I believe are the most important pieces of information. Oh, that's so cool. The most important pieces of information that oh, okay, Camille, we'll take care of that in school tomorrow. And then let's see, I'm losing my train of thought. Most important pieces of information. Now, there is absolutely going to be more things than what's on this sheet on your EOC, okay? I am not a mind reader. I'm just telling you this is what my best guess is based on my understanding of the Common Core State Standards and Georgia's expectation and reading that 180-page book about what questions they cover. So I just hope it helps you. All right. So we're not going to spend a whole lot of time. I'm not going to make this an hour and a half video. I'm going to go over the overview. Then you are going to jump on to Hey Jazz, my playlist. And from my playlist, you're going to pick what you need. So let me real quick review my expectations for the playlist. So we have it now set up. You guys are really, really being awesome and kicking booty when it comes to your commitment and dedication to have a growth mindset. Basically, if we look right now at our dashboard, you guys have hit 4,000 views. Can you imagine? 4,043 views. We're up to 59 subscribers. I'm totally stoked and proud of you. Now, you can, if you, clearly you're here because I've been putting the links in, but you could always just type in South Gwinnett geometry now. And when you do that, our page comes right up. So click on my name. Here's all of our videos. If you click on my name down here, I created a playlist for you. Here's what we're doing right now. Down here's the Geometry EOC Review playlist. Now, we are going to be doing more of these in the 2 weeks to get prepared for the district assessment. But this is what I want you to do tonight. I am going to go over our quick stuff. This right here, the GOT, greatest of all time EOC review. That's what I really want you to spend your night watching if you haven't seen it or if you did not participate last night. Down here is kind of the order I want it to go, and it's actually in reverse order because the GOAT review covers a lot of unit 1, 2, and 3. So I want you to refresh your memory. Now, the EOC book, the Georgia book, it says that 15% of the questions come from probability. So that being said, if you have time to go over those 50 minutes, even if you just fast forward it, and what I mean by this is like, if you just skip forward and you look for those EOC questions to pop up, it comes up, I think, around 20 minutes something, then that is going to help you. So you can miss my whole conversation, but as soon as you get to this, these are all our EOC questions that I took right from the EOC manual. So that is where you can spend your time. Don't feel like, oh my gosh, this whole thing is 46 minutes on right triangles. I don't want to watch 46 minutes. Don't. Fast forward till you get to the questions. And here, the questions here come around 21 minutes. That's all me pre-teaching. And just focus on learning these questions. That's going to give you the biggest bang for your buck to help you prepare. So I would say I would do at a minimum the GOAT. Then you can go into probability because you know you're going to see, 15% of 70 questions is going to rock you about 10 questions at least. Volume density and modeling was a huge thing. There was a ton of questions on that. But again, feel free to jump forward. Now, the only two that you really don't need to look at unless it's a struggle for you are these geometry reviews, because that's when I go back to the basics, like how to do stuff from algebra that you should already know how to do. Okay. But rocking that playlist is where it's going to be. In another week and a half, it's going to be rocking the playlist for the district assessment. That's going to get you the most prepared. So let's take a look here. Crazy quick EOC geometry review. Actually, you know what I'm going to do since we have kids from other schools? Let me real quick jump up and put the link for you. Let's see. Hold on. I think what I'm going to do is I will upload this doc for you. Ginger, you need to chill out, baby girl. Let's just make sure that it's the right crazy review. And then I will put the link sharing on so you can look at this if you need it. That is it. So I'm going to get shareable link. All right. And let me go over here. And, for right now, I'll just put it in these comments. I'm not going to be all extra. So there is what you can click on if you don't have what I'm going to go over tonight. Okay. So our friend from Central, there you go. That's what we're doing. Okay, so here we go. Transformations. Okay, we're going to see if we can get this baby done in like 10. Well, transformation, we're going to try to knock out in 5 minutes. Okay, there are 3 types of transformations that relate to rigid motion. Those transformations, whenever we have rigid motion, it stands for congruent and similar. These are translation, slide to the left, slide to the right. Translations, still Miss Erig, nothing about me changes. Reflection, I'm looking at you through the video. The camera has me obviously flipping around. Okay, that right there is reflection. My size doesn't change. Congruent, similar. Congruent and similar always go together. You will not have something that's congruent and not similar. That just does not happen. It's like congruent, similar. It used to be peanut butter and jelly, but now it's like almond butter, cashew butter, and jelly. But you got to have congruent. If it's congruent, guaranteed similar no matter what. So you got translation, reflection, and then, of course, the rotation. So like me spinning, I'm rotating. That's different. Excuse me, Ginger. Everything's okay. Please calm down. That's different than dilation. Dilation is similar only. It's like similar, full stop. Nothing else happens. Similar only. Okay. If it is similar, it is not congruent. Well, it's not necessarily congruent. Okay. If something's congruent, it is similar. So for example, if I had 2 water bottles, they would be congruent and similar. But if it's similar, it's not necessarily congruent. Typically, how I've told you is when you're looking for scale factor, that's when we get that big to small. Okay. Why did I type that? I typically say new over old. Oh, that's not why I put big to small there. Big to small means even though it says dilation, some kids just think it gets bigger, but dilations also can get smaller. So if the scale factor is greater than 1, then you know it got bigger. If the scale factor is less than 1, then it got smaller. Okay, so dilations get bigger and smaller. Hey guys, welcome, welcome. What you need to memorize for when you walk inside is sides, proportional, angles, same. When we have similar figures, we say sides, proportional, angles, same. In the privacy of your own bedroom, please repeat after me. Similar figures. I can't hear you. I'm just kidding. But similar figures, say it out loud. You got to activate and get your whole brain teaching going, okay? Similar figures. Sides, proportional. Angles, same. Similar figures. Sides, proportional. Angles, same. Okay, you got to remember that. Here's another thing that I am very much suspect you're going to see on your EOC. One of the core beliefs in geometry is that all circles are similar. And what that means is you're not going to have part of the circle get big and the other part stay small. That just doesn't happen. You need to make sure that it grows at the same rate and shrinks at the same rate. If you think of how you're blowing up a balloon, it gets bigger at the same rate and it gets smaller at the same rate. Thank you very much, Sammy. You rock. Okay. Now, what's the official wordage for all circles are similar? The ratio of the diameter to the circumference is the same. The ratio to the diameter to the circumference is the same. Basically, they're talking about pi. Okay. Now, whenever you have all circles similar, this is what happens. Excuse me. Come over here, Ginger. Okay. Here, when you have all circles similar, basically you would have one circle here and another circle here. If it says what happened, like what transformation happened, 2 transformations happen when you have all circles are similar. The first transformation happens is the center gets translated. In this case, the center moved from here and went over there. Okay. That happens first, translating the center. The second thing that happens is the radius either got bigger or it got smaller. Okay. 2 things happen. All circles are similar because of the ratio between the diameter and the circumference. And what happens? 2 things. You move the center, and it gets bigger or it gets smaller. How do we determine how it gets bigger or smaller? That's where it comes in. Your new radius is divided by the old radius. Always new divided by old whenever you determine scale factor. Always new divided by old for scale factor. Repeat after me. New divided by old for scale factor. I almost want to say sing it with me. New divided by old is scale factor. Get that. Okay. Now, you might get a center of dilation question. Part of me really hopes you do because it's kind of easy. How do we do center of dilation? Well, all we're going to do is you're going to have yourself that shape. Okay. And you're going to have another shape. And you'll be like, where's that center of dilation? All you do is you connect your points. Wherever they intersect is that center of dilation. And that's what this says. You connect. Woo! Would have been helpful if I used a highlighter tool. You connect the corners, and where you connect the corners for all those shapes, wherever they intersect, that is your center of dilation. Next, I pretty much believe you're going to get a rotational symmetry question because it's another core concept. Most of these things are core concepts in geometry. So what is rotational symmetry? Well, it only works for regular polygons, which pretty much means all the sides are the same. Okay. What you're going to do is you're going to take 360. Now, where have I heard that number 360 before? Oh, circles are 360 degrees. So you have to think, oh yeah, circle, rotation symmetry. It makes sense. Be sure this is closed because when I rotate something, it forms a circle. So rotational symmetry, we think of a circle. We take however many sides the shape has. So if I have a perfect square that has 4 sides, so I would take 360. I would divide that baby by 4 and get 90 degrees. So every 90 degrees, I'm going to multiply 90 by 1, 90. 90 times 2, 180. 90 times 3, 270. 90 times 4, 360. What? We hit 360, 360. That means we stop. So these are our rotational symmetries. You have to remember, not only are you going to divide by the number of sides, you also are going to multiply by 1, 2, 3, 4, 5 until you get to 360. Because adults like to trick you, okay? The EOC wants to trick you. They're not going to be nice and be like, dude, you rotate at 90 degrees. You're going to have to do work, okay? And you do the work by multiplying by 1, 2, 3, 4, 5, etc. Okay? Now, that's the end of transformations. That's pretty much the most important stuff. Is there a ton of other stuff? Yes, but this is the most important stuff. Other things real quick to remember, like when you do reflection, if the lines go up and down and you're reflecting like over this line, you're going to count going straight. If you're reflecting over diagonal, you're going to count on the diagonal. If you don't know about that kind of stuff, you can watch the GOAT, greatest of all time video I made last night to help you out. Okay, next things. These things are the most, if you had to only memorize 2 things. Now, I would love for you to memorize everything in terms of constructions. I really would. But if you had to pick your top 2, these would be the top 2 I would pick. The reason is I saw a lot of questions on angle bisectors and perpendicular bisectors in that Milestones book that they published online. So angle bisectors look like this. Here's our angle. In order to bisect or create 2 equally sized smaller angles, you're going to put your compass right here. Here's my pretty compass. Then you're going to draw your arc. Arc. It doesn't matter where you draw the arc as long as it's inside the angle. Okay. After you do that, you're going to put your compass on this dot right here, this intersection. And you're going to be like, let me make another arc that's greater than half. Then you're going to put it on this one. And you're going to say, let me make another arc that's greater than half. And see where these cross? Boom, angle bisector. What do we know about it? An angle bisector divides the angle in half, and each mini angle is half of the larger angle. Then we're going to talk about perpendicular bisectors. Well, a perpendicular bisector divides the line in half and creates right angles. How do we do a perpendicular bisector? Here's our line. We pick a point the point that we're dividing. Then we pick an arc that's more than halfway across. And then you have to draw a circle, so important, on the top and bottom. So if I was doing it, I'd be going, I know y'all like the sound effects. Here we go. Put my compass here. See where they intersect, boom, shebang, draw your line perpendicular bisector. So these would be the 2 that I would expect that you probably will get at least 1 question on, maybe 2. I mean, I don't know. I haven't seen anything. Even if I did see it, I couldn't say anything. But those were the questions I saw the most of, are those 2 things. There's other things like parallel lines, copying an angle. I talk about all of that in the longer constructions video. Congratulations. We just finished Unit 1. Okay, Unit 2, similarity, congruence, and proofs. 35% of your test is on transformation, similarity, congruence, and proofs. Where have I heard similarity for? Oh, yeah, in transformations. Okay. I was trying to kill a fly, but it didn't work. Okay, similarity. Here I have make sure the lines match roof to roof. There was a question that I had you guys do that was like, what's this compared to this? And what's this? And then, oops, wrong color. And then you had one that was like this one and this one. Do you see how it makes sense that the yellow lines are right on top of each other? Not necessarily on top, but it's like the same size of the house. But look at here, the blue, this is a roof, and this is a wall. A roof and wall are 2 different parts of your house. So whenever you look at similarities and you're looking at those proportions, you need to make sure that the side of the house and the side of the house and the roof and the roof, that's what you want to make sure that you have. Now, I already talked to you about scale factor, but let me say it again. Scale factor, new over old. Scale factor will always be your new shape. Remember, your new shape is the shape that's got that little line next to it, the prime. Your new shape divided by something from the old shape. Okay, so the new line divided by the old line, the new measurement divided by the old measurement. Now, this is where they get you a little bit sneaky, though. Technically speaking, Dario, man, you have been working so hard, and so many of you have been working hard. 170 of you have passed and turned in your EOC projects. I am confident you guys are going to kill it tomorrow and Thursday. So there is nothing to be stressing about. I believe in all of you. And heck, it is 7 o'clock some at night, and you are sitting on the computer, and some of you have been watching videos over the weekend and more time. So I truly believe if you put the effort in, you will see the results. Okay. All right, let's keep going. So proportions. I have told you that the scale factor is always new over old. Okay. Here's what happens. Proportions don't necessarily have to be new over old. What they have to be is new over old and new over old. Or, hey, Shamori, good to see you, sweetie. Or old over new and old over new. And what I mean by this is this. You need to make sure that it looks like this because those make sense. You don't want it to look like this. And let me explain. Okay? When you cross multiply, you need to make sure that you get an O and an N and an O and an N. Okay? That is so critical. See how we have an O here times an O times an N, an O times an N, an O times an N. Here, look at this red one. We get an O times an O, and it's like an uh-oh. You don't want that. N times an N. Nope. You don't want that either. So what you're going to be doing is this. Why aren't you going back, mister? You need to make sure that you do the things in green. This is the stuff that we want. Exactly, Sammy. That's exactly what I'm doing. So Sammy knows my dating example because he, poor guy, has heard it like 4 or 5 times. If you are dating someone, okay, you are on. Congratulations. You are dating someone. And when you are going out and dating someone, you are actually going on dates because that's what dating someone means. If by some chance you are not dating someone, it's probably likely that you're not going on dates. Okay. New, old, new, old, old, new, old, new. It makes no sense that you would not be dating someone and going on dates. That makes no sense. If you're not dating someone, no dating, why are you going on dates? Don't date somebody you're not dating. Don't go out on dates with somebody. Don't go out and hang out with somebody else's person. You don't do that. You either are dating someone and going on dates, or you're not dating someone and not going on dates. You need to remember new, old, on, old, new, old, new. All right, I'm done with talking about that example. Okay, next, side proportionals, angles, same. I made you say that already. Sides proportional, angles are the same. That's what we get from we get dilations in similar figures. Now let's talk about some proof theorems. Vertical angles. Now, this is just my personal observation. There are so many other geometry teachers who know a heck of a lot more about geometry than I do. Okay. However, I have seen enough proofs to recognize that if we see this bow tie picture right here, 90% of the time, if you are doing a proof and you see a bow tie and you are proving triangles congruent, you are going to be using vertical angles with these 2 little X angles or inside angles around that C. The reason is because it makes sense. So if you see a bow tie, see if it's a vertical angles because vertical angles make the bow tie. Okay. Next, this one. Now you will probably see something where it mentions something like these 2 lines, it tells you in the given, these lines are parallel. Okay. If you are proving something congruent and they tell you parallel and congruent, so it gives you something that's parallel and you're proving congruent triangles. Most likely, here's an example, parallel lines, and we're proving those triangles congruent. Most likely, you're going to get this angle and this angle to be alternate interior angles. Now, you do want to make sure that the angle that you pick touches that parallel line. Okay. Hey, Christina. Okay. The reason is that's the whole purpose of alternate interior angles. They touch the parallel line. So if you see something like this, or you see them having a proof that uses parallel and congruent, you're pretty much going to get alternate interior angles. If you see something that says parallel and similar, you are most likely going to end up using corresponding angles. And the picture from the EOC book was, it was something like this. And you're proving this blue triangle congruent to the bigger pink triangle. And we would have used corresponding angles to get this if these two lines were the same. So if you get parallel and similar, you're going to be doing corresponding. If you get parallel congruent, most likely it's going to be alternate interior angles. Next is the perpendicular bisector. Remember that a perpendicular bisector bisects the sides, creates right angles, and if you really want to be cool, it also makes these opposing sides the same by the perpendicular bisector theorem. The midpoint, or you would even see the word just plain old good old bisector, okay, that divides the line into congruent statements. So this problem might have been the one where it was like AC is the bisector of something, something. So you might see bisector meaning halves. Isosceles triangles, those base angles are going to give you angle, angle like that. Okay. Opposite sides are congruent. Mid-segment, I don't recollect seeing one mid-segment question, but if you do, a mid-segment is you have a triangle, you find the midpoints of each of the sides of the triangle. When you do that, you've now created mid-segments. This right here is 1/2 this whole thing. Basically, it's saying that this part right here, and I'll put it in pink, this line is this equal to that line, and it's equal to that line. That's what mid-segment does, okay? I didn't see any questions on it on the EOC book, but that's possible. You might see something that says reflexive. Remember, reflexives of what they share. So here's a picture from an EOC problem. In this case, in order for us to get DF, we'd need DH and FJ to be the same, because then we could just add on the HF because the HF is shared, okay? Now, here comes the sandwich story. We have a couple things. You know that you can use side, angle, side, 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 angle, side, angle, hypotenuse, leg, angle, angle, side. Now, when you have side, angle, side, and when you have angle, side, angle, you have to make sure that you make a sandwich. And what I mean by making a sandwich is that you have your piece of bread, side, your other piece of bread, side, and inside my smiling face is your angle. Or you have your angle, here's your piece of bread, your angle piece of bread, and on the inside is your smiling face for the side. If we look at this picture here, we would have to have angle, angle, and then side. We could not have side and then this angle and this angle, because look at that side is not between the two angles. So it doesn't make a sandwich. It's like a piece of bread and a piece of bread and your fluffernutter on top. That makes no sense. You need to have your piece of bread. You need to have your fluffernutter marshmallows. Then you have your piece of bread and then you can eat your sandwich. Okay. So this would be angle, angle, side, because the side is not between the pieces of bread. All right. I'm going to move on. There's a whole lot of facts that you need to know. These are my top facts that I would expect that you would need to know. I put them underneath Unit 2, but they're also relevant to Unit 5 modeling. Parallelograms have opposite sides congruent, opposite angles congruent. The diagonals bisect each other. Okay, guaranteed all parallelograms. If the diagonals bisect each other, then you can say it's a parallelogram. If the diagonals are congruent, you can also say it's a rectangle. Now, technically speaking, if they are perpendicular, it's a rhombus. And if they're congruent and perpendicular and they bisect each other, it's a square. But this is the main stuff because most of the questions I've seen have to deal with rectangles. Next. Yay! Congratulations! We've just finished Unit 2. Here comes Unit 3. Okay. First, Pythagorean Theorem. Dude, use the Pythagorean Theorem as much as possible. It's way easier than the distance formula, especially if a grid and you can just count. Pythagorean Theorem is a squared plus b squared equals c squared. C squared is always the hypotenuse or the longest side. Guess what? This is on your formula sheet. You don't have to memorize it. Okay, C has to be the hypotenuse. It doesn't matter where the a's and b's are. Pythagorean Theorem, done. Trigonometry. This right here is literally from the EOC book. You are going to get the trig ratios. You don't have to memorize them. What you do have to memorize is where they are located. So let me show you. Here we have our right triangle. We know it's a right triangle because it has a right angle. Opposite the right angle, you know, is the hypotenuse. You just know this. Theta is always the angle you're talking about. So here it shows you theta. Here it tells you angle A. So if I make this theta, now I'm going to look, okay, what's opposite theta? Well, if this is opposite the hypotenuse, remember we had to walk across the triangle to get to the other side, just like how the chicken crossed the road. This theta's got to walk to the other side to become the opposite. Then the other one is the adjacent. I always label hypotenuse, opposite, and then adjacent because it's just how I've done it. Some people do angle and then think of angle touches the adjacent side. It doesn't matter. The main thing is once you get two of those numbers, then that's where this comes in. Now, one of those numbers can be X. You could have something like this, and this is your theta, and they give you X here and 5 here. Technically, X is a term, and so that works, and you could do sine. Opposite 5 over hypotenuse X. Okay. If you need the sides, you're using the trig ratios. If you need the angles, you'll be using the inverse button. And basically, it makes it look like this. Sine -1, cos -1, tan -1. All right. All right. That's all I'm going to talk to you about for this, because you can watch the trig video if you need more help. So yay. Congratulations. We have just finished trig. Next. Okay. There's a whole lot of stuff going on this sheet. Okay. Basically, central angles, I've said this like gazillions of times. If you're one of my students, the central angles have the vertex at the center of the circle, and the angle measures are the same. You know, even though they're C's and S's, they still give you a okay, central angles are the same. All these other ones, you will always end up dividing by 1/2 when you go from the arc to the angle. Now, sometimes you have to do something first. So like for here, where you have the internal angle and it kind of looks like a plus sign, you have to add those arcs first, and then you divide by 2. If it's an external angle, you have to subtract the arcs first, and then you divide by 2. If it's just an inscribed, you just divide by 2. Now, remember our little hand gestures. So like put your cell phone down and get your hands ready. Arc to angle, we divide by 2. So we're making this. Here's our beautiful arc of our circle. We go down to our point of our angle. So like an ice cream cone, the ice cream's the arc. The bottom of the cone is the angle. Hey, Bryson, arc to angle, we divide by 2. Angle to arc, we multiply by 2. And just, it keeps flowing. Like, look at this. Angle to arc, we multiply by 2. That was Quante who gave me that last part. So arc to angle, divide by 2. Angle to arc, you multiply by 2. Here's what sucks. We hardly give you any formulas for circles. So you really need to know what these are in order to be prepared for your EOC test. Okay, there you go. I'm going to not go into that. The only other thing you might need to know is like, here's my pretty circle. Here's my angle. And they tell you that this measure is, let's say 70. And they want to know this up here. So you just have to remember to take 360 degrees, subtract your 70 degrees, and then you get whatever you need. Okay. Next, anytime you have a tangent, I have it down here and here where it intersects, where it touches, that is called the point of tangency. That forms a right angle. Also, speaking with tangents, if you have two tangents that come out to a point and create your little hat, these lines are congruent. Okay. Anytime that you have an inscribed angle and your inscribed angle has the endpoints on the diameter of the circle, because the diameter circle takes the circle and cuts it in half, 180 degrees, using inscribed angle, arc to angle, half of 180 is 90 degrees. That's where you're going to get that right angle. This will be on your test. I can guarantee it. I really can't guarantee it, but I'm pretty sure it is. It's another fundamental geometry concept. Opposite angles of inscribed shapes equal 180 degrees. They're supplementary. So you got to remember that. Opposite angles, 180. Okay. Moving on to segment relationships. We have our pretty X here. Now, this is what kids get confused on. Let me trace this. We're like, what is this picture compared to this picture? They look exactly the same. They do look exactly the same because there's two chords. Here's two chords bisecting each other, or not bisecting, but two chords intersecting each other. Here's two chords intersecting each other. In this one, we're talking about the angle measures. Here, we're talking about the actual length of the lines, the segments. Part equals part. Okay, part times part equals part times part. That one, if you have two lines that are parallel, The intercepted arcs are the same. This is where we do ow. Let's talk about ow real quick because I love ow. And if you remember it, you got it. I want you to think of good old Sleeping Beauty. Oh, she was just such a wonderful princess. And she had to prick her finger on the spinning wheel. And then she fell asleep and had to get rescued. How unfortunate. Here's my spinning wheel. I put my finger on and I'm like, ow, I just pricked my finger. What does ow stand for? Outside. And if I would have waited and given you wait time, I know most of you know this already, over whole. So I'm going to take this outside piece and I'm going to multiply it by this whole piece. Take this outside piece and multiply it by this whole piece. It also works for tangent. Outside times whole, outside times whole. Okay. Here's the issue. It is way easier if you take your time on this test. Like you would make your geometry teacher, me, happy if you take at least 75 to 80 minutes. If I hear you got less than 60, I'm going to be kind of sad because I don't know if you actually worked all the problems out. Growth mindset, honeys, you got to work all those problems out. You've been working so hard. Why do you want to give up when you're actually sitting down in front of that test? So here, what I expect you to do is if you see something like this and it wants to know the length of the segment, I expect you to write down O and put whatever that number is. I expect you to write down W and put whatever that number is. That way, it's so much easier because then, let's say this one, the outside equals 3 and the whole equals 10. It's so much easier to go like this. That was a 3 and then cross multiply because you're not holding it in your head. Okay. Remember, there are 3 types of memory. And there's short-term memory, there's active working memory, and there's long-term memory. Technically, there's more, but we're just going to cover those 3. Short-term memory is memory that you hold. Hey, Ariana, memory that you hold in your mind for 15 to 20 seconds. It's like, here's a phone number. Or what do I want to get for lunch today? Or how much money do I need to check out? Those are all things that are quick, short-term memory things. Hold, please. Active working memory is what you guys are going to be working on tomorrow and Wednesday or Thursday when you take your test. Active working memory is you're pulling information from your long-term memory, you're applying stuff from your short-term memory that you just did the question, and you're trying to manage that all at the same time. It's like picture your phone. How hard is it to multitask and have like 4 or 5 apps open? Like Slither.io. Man, I love playing Slither.io, but if you switch to another app, forget it. You're dead. You sacrificed yourself and your guy is gone. It happens. If you write stuff down, you are taking the load off of your active working memory. It's kind of giving you permission to check another app and then come back to Slither.io and you don't sacrifice yourself. You need to write stuff down. It can even be taking a piece of paper, holding it up on the computer screen, tracing the shape, and then answering the question that way. But please write it down, especially for these questions. All right, I think I pushed that enough. Let's keep going. When we have our intersected lines here, okay, we know that the opposing sides or the opposing arcs are the same. And then this says if a diameter radius is perpendicular to the chord, then it creates congruent segments. Yay, congratulations, you finished Unit 4. Okay, Unit 5 and 6 at South Gwinnett, they do together on the EOC review book, so I'm just talking about it together. I'm going to give you a free question right here. Now, again, everything on here is super uber important. But if you can remember this about Cavaliere's Principle, I would be astounded if someone came to me and said, Miss Erig, I didn't see one Cavaliere's Principle question. Because Cavaliere's Principle is like a foundational geometry topic. Here's the secret to breaking Cavaliere's Principle. You are going to have the same volume if you see 3 magic words: parallel, area, and cross-section. It can be in any order, but if you see parallel, it might say parallel lines, it might say parallel planes, it might even say height, to be frank with you. But more often than not, I expect it'll say parallel on the state test. So if you see parallel, hey Cordelia, and you see area, and you see cross-section, you can bet your bottom dollar it's Cavaliere's Principle. So that right there is a free question. Okay, coming up, circles. This formula is on your formula sheet. What you need to remember is if you move from the formula to the center, you need to switch the signs. I had an awesome student stay after school today and say, Miss Erig, why did I get a 40 on my retest? And I said, let's take a look. You know what happened? Did not switch the signs. You need to switch the signs. If you are going from formula to the center or the center to the formula, you need to switch the signs. If you are going from the formula to the radius, you need to take the square root of that number in here because the formula says it equals radius squared. If you are going from radius to the formula and you're plugging the number into the formula because you're creating it, then you need to make sure that you square it. Like hands down basic stuff, you need to know what you are going to see questions like that on your test. 15% of your test is circles. Okay, radius. Let's say they give you 2 points and they're like, dude, what's the radius? Is something inside the circle, on the circle, or outside the circle? You're going to need to use the distance formula, and you're going to do it with the 2 points, the center, and the radius. I have an amazing math hack that kicks butt. I'm not going to show it to you. So you need to watch the circle video if you need help with that. But you're the math hack to do distance formula, or you can use the formula on the formula sheet. We know that it's a long, drawn-out process to go from general to standard form. Basically, you're completing the square twice. My tip that I told you is you group the x, leave a space, group the y, leave a space, and then move to the constant to the other side by subtracting or flipping the signs. Then you set it up. How do you remember how to set it up? Dude, hey, welcome. Dude, how do you do it? You look at the formula sheet because it tells you how to do it. That's how you set it up. So how do we fill the numbers in? Well, we go down by dividing by 2 and we go up by squaring it. So if you don't know how to do that, it would be worth looking at my circles thing and fast forwarding till you see it. It might be in circles and it might be in volume density. It's actually in volume density and modeling. Okay, next, slope, slope, slope. We like slope. Y equals mx plus b. When I say, does anyone know the formula for slope? I hear this all the time. Remember, any number that comes before that x, that's your slope. Okay. If it tells you that something is parallel, you need to make sure that you rock the same slope. So if it says parallel, dude, cross out the ones that are the opposite reciprocal because it's not going to be your answers. Then at least you have a 50-50 chance. If it asks you for perpendicular, let's say you have 4 as the slope. Okay, your perpendicular would be the opposite of positive is negative, and then flipping it over, you get negative 1/4. So you'd cross out anything else that's parallel. So right away, look at the slope. Find the slope if it's parallel, and then ask, is it parallel? And then plug it into y equals mx plus b. Okay, opposite reciprocal. You got to know that. You got to know all this stuff that I have on here for you. All of it is amazing. Okay. Frankly, this I did in the last 5 minutes. So this I copied directly from the EOC book. Okay. So I can't take credit for it, but I'm going to educate you on this information. In probability, it says sample space is a set of all possible outcomes. Now, there are 3, 99% sure, there are 3 probability formulas on the formula sheet. You are looking for matching words. Actually, you know what? Let's take 2 seconds and pull up that formula sheet for you. Georgia geometry EOC formula sheet. Yep, I was right. There's 3 formulas on here for you. Now, if you notice, I did not mention directed line segment. I did not mention arc length, area of a sector, because those are all things that you should know already, and you just have to plug in the formula. So it is on you to watch those videos to get that information. Okay, here we go. So here are our 3 formulas on the formula sheet that relate to probability. Don't get big, don't get big, don't get big. Okay, so see this. Whoops, that's not going to help me, is it? Technical difficulties, please stand by. Come on, babe. Shrink. Why are you not shrinking? All right, maybe it won't let me do it. That's suck-a-doodle-doos. Yep, it's not going to let me do it. Let's see. Will you let me go side to side? All right, it will let me go side to side. So we'll do side to side. So we have this here, and we have 3 formulas: conditional probability, multiplication rule for independent events, and also addition rule. So if we look here, if the outcome of one event does not change the possible outcomes than the other events, then it's considered independent. Okay, here's an example. If an outcome does change, then it's dependent. If you have, I know it's a whole lot. I agree, Sammy. If you have a deck of cards, okay, if you pull a jack, just because you pull a jack, it doesn't mean your next card is going to be a 4. Those are independent events, especially if you replace the card, okay? If you keep the card in your hand, you went from 52 cards in your deck down to 51 cards. So that became dependent. Intersection happens when you have the overlap between two items. And let me talk about that because my picture is so awesome at intersections. I completely borrowed it from someone else, but we're going to rock it. And it's all in your books that you made for me. Okay, so let's take a look at this picture. When you have Venn diagrams is the example, but when you have intersection, that is the overlap between two things right here, intersection. So for example, if two people fall in love and they get married and they have a baby, their baby is their intersection. DNA and DNA smashing together, intersection. When they get married, though, it's not like they're just, oh, this is what we have together. It's like, I'm bringing all my stuff, all your stuff in the house. We add the whole shebang. Now, we don't add the stuff that's duplicate. So for example, if I have a can opener and my partner has a can opener, we don't need 2 can openers. So we're going to get rid of 1 can opener to Goodwill. Okay. So this overlap, you have to subtract at the end. This formula is called the addition rule. It's on your formula sheet. If you have something that's complement, okay, complement is whatever it's not. So for example, today it did not rain. So the complement of sun would be rain. If something is odd, its complement would be even. All right. Mutually exclusive means that the two things can happen at one time. So in my class, we did question something like, a person having blonde hair and blue eyes. Is that possible? Yes. So it's not mutually exclusive. Can a person go and vote for 2 presidents at the exact same time? Nope. So that would be mutually exclusive. Sometimes some people mix up the words independent and mutually exclusive. So if you see a problem that says independent and doesn't have any numbers, they pretty much mean mutually exclusive. It's asking you, can the two things happen at once? And that's where that comes from. And then down here is the formula for independence. All right, I'm going to stop right here because frankly, I just want to give you my last 2 cents and really drive some things home. So here's the thing. Oh, that makes me look extremely blurry, but that's all right. You guys freaking rock, okay? Most of you have been really pushing yourselves and working hard. Here it is the night before some of your tests, and you are choosing to watch yet another video that we put together. So I am just encouraging you. Please don't stay up late studying. If you don't know it in the next half hour, 45 minutes, you might not know it. If you need to refresh your memory, definitely refresh your memory. But I don't want to hear that you were up to 1 or 2 in the morning studying. That's not going to make me proud. That's going to make me think, OMG, get your act together. You should have slept before you took your test. Okay. You need to make sure that you do everything you can to eat a breakfast in the morning. I don't want you sitting down for the test hungry. And I don't want you getting hungry at 9 o'clock because then you're going to be focused on your hunger for your belly and you're not going to be thinking with your brains. So you need to eat something in the morning for breakfast, preferably something that's not like a candy bar and a soda pop. Okay. Get something a little bit healthier inside your system. Next, I fully expect you to take every single minute of your test. Okay. Don't feel rushed. Don't feel like, oh, everyone else wants to get up. I need to get done. No, you be selfish. Tomorrow or Thursday, I want you to be selfish for you. You do your best on your test so that when you walk out of that room, you might not say, man, I got a 90 on that test, but you can walk out of that room proud of yourself saying, I earned the best score I could possibly earn with the knowledge I know right now. Okay. With a growth mindset, it's not like you're going to take the geometry EOC test again. Okay. But you will be taking the district assessment coming up, especially if you live in Gwinnett County. So I want you walking out of that room, not necessarily proud of the score that you got, which you might be, but I want you to be proud of the effort and work that you've put into it because you have worked so hard. Okay. Now I believe in every single one of you. The fact that you're watching this right now makes me so unbelievably, incredibly proud of you. I know that if you walk in tomorrow or on Thursday or whenever you're taking your EOC and you walk in confident and you walk in knowing that you took time to prepare, you will fare much better than doubting yourself and saying, oh, I should have studied more. Okay. So please take the time to review, take the time to study, spend just a little bit of time. You don't have to watch all 6 hours of videos. Fast forward and watch what you need to know. See what you need to know. Okay. But you can do this. You can surprise yourself. You're not going to surprise me because I've already always known that you're awesome, but you're going to surprise yourself. And I truly believe in you. So I'm going to end our little session just like that. You guys are awesome. Like, you're just amazing. I hope you know that. And then, yeah. Oh, what's your question? Can I put the milestone grade conversion chart on Google Classroom? Nope. Your test I did put on when you're taking the test. That is on eClass. Yep, I ignored your question. I'm sorry, but I got you now, Cordelia. All right, so I'm going to leave it like that because I had to give my little piece out. You guys are awesome. Okay, so spend some time together. Get it from there. I don't want to give you the grade conversion because that's just my work. That's not official. Okay. All right, we're going to go from there. Peace, guys. Do awesome. I'll see you in school tomorrow. Thank you for joining us. If you're not from Gwinnett, ciao.